tonight. Okay, so we're looking this evening at working through the intermediate numeracy paper, the paper 2, calculator allowed, from June 2017. Question 1. So we've got information here on a bus timetable from Orme Station to Outlet Village. It only takes 55 minutes from Orme Station to the Outlet Village, and buses leave the station every 12 minutes from 8 AM until 12 noon, and after that every 24 minutes from 12 noon until 10 PM. So the first question, it is a question, is at what time does the first bus after 9 o'clock leave Orme Station? So straight away here we can use the calculator to help us. You could write a long list, but on your calculator you've got the time button. The time button is the one that looks like a series of commas and full stops. Okay? And you press that in between every hour and minute. So I'm interested in the buses leaving Orme Station in the morning. So I'm starting off using that information there. They leave every 12 minutes, starting at 8 o'clock. So on my calculator, I'm going to type in 8 hours, no minutes. So that represents 8 o'clock. Okay, so 8, time button, 0, time button. And then I'm going to add to that 12 minutes. I have to put in the hours, so 0 hours, 12 minutes. Then I press equals. And that tells me the time the next bus is going to come, which is at 8:12. Now I want to add to that another 12 minutes. But rather than clearing it, I'm just going to put press the plus, and then 0 hours, 12 minutes again. So my screen is saying answer, the previous answer, plus another 12 minutes. And now every time I press the equal sign, it's adding 12 minutes for me. So there's a bus that leaves at 9 o'clock. But the question is saying, at what time does the first bus after 9 o'clock leave? So it's not the 9 o'clock bus, it's the 9:12. Part B. Gwyll looks at the timetable shown above. He decides to take the latest possible bus to be at Outlet Village by 1500, 3 o'clock in the afternoon. What's the question? At what time will he arrive at the Outlet Village? Now, what information am I given here to help me with that? It's telling me that the journey takes 55 minutes. So that means if the journey takes 55 minutes, he has to leave the bus stop 55 minutes before that at the latest.
So
Yeah.
the first question, does that mean that there's definitely a bus at 9?
Yeah.
Okay.
But the question is saying after 9.
Yeah.
Is that okay?
Yeah.
So coming back to part B, if he's got to get there by 3 o'clock and it's a 55-minute journey, he must catch a bus no later than 14:05 in order to get there by 3 o'clock. Now these buses, because we're now in the afternoon, are running every 24 minutes from midday. So I'm going to repeat now what I did the first time. I'm going to start at 12 noon. So my time button, 12, time button, no minutes. Add, and then every 24 minutes will be no hours, 24 minutes. Press equals. Oops. Did I do wrong there? 12 hours plus no hours 24 minutes. Put the first one in. Then you've got to do add no hours 24 minutes. And then every time you press it. So there's one at 12:48. Okay, you could write these down if you wanted to. The next one's at 12 minutes past 1. Then there's one at 13:36. One at 2 o'clock exactly. And then the next one will take us past that because I have to leave by then. So the latest bus he can catch is 2 o'clock. But that doesn't answer the question. Because the question isn't what's the latest bus he can catch, it's at what time will he arrive at the outlet village. So if the bus is leaving at 2 and it's a 55-minute journey, so he arrives at 14:55. Okay, so you don't need to use the time button to do that. You can just list the times. That doesn't matter. The most important bit and the most common mistake students were using was that they were cycling through that, but they kept going to that point. And they'd say, oh, they get there at 14:48, missing the fact that there's actually a 55-minute journey. So the way that one is marked, it's a straightforward B mark for that, which means if I see it, you get it. And then for the second one, there's 2 marks if I see 14:55. But if I do see 14:48, so you're counting on correctly, you will get 1 mark. But those are both, I'm just looking for answers. There's no method marks. Question 2. Luigi lives in South Wales. Rosina lives in West Wales. For each of the first 65 days of 2017, they recorded whether or not it rained. Luigi recorded that it rained on 28 of these days, and Rosina recorded that it rained on 40% of these days. Luigi says, for the first 65 days of 2017, there were more days with rain where I live than where Rosina lives. Is Luigi correct? So there's my question that I've got to answer. Then I look at the information I'm given in order to answer it. There's 2 ways you can do this. The easiest way, the most popular way, when I was marking this last year, was to work out what 40% of 65 is. Half. I'll show you now. Okay? So, Rosina recorded 40% of, you have to write as times, 65. Now, if this was on a paper 1, you'd find 10%, etc., etc., etc. But because we can use a calculator, our calculator has got a percent button on it, which is, it's not coming up very clear here, it's above the open bracket where my pen is pointing. Okay? See that percent there? So you can type this in exactly as we've written it. 40% times 65. Press equals and you get 26. Yeah, 40 over 100 times 65, same thing. Writing is a decimal, 0.4. That's fine, whatever way makes you comfortable. But if you're writing it as 40 over 100, it's an extra step you might make a mistake on. The percent button takes all of that out of it for you. So, is Luigi correct? Well, Rosina was wet on 26 days. Luigi was correct on 28 days. So, to answer the question, yes, Luigi is correct because it rained 28 days where he lived, compared to 26 where she lived. The marks for that, there's a method mark for working out 40% and showing how you do it, and an answer mark if I see 26. If I see 26, doesn't matter about the method, you get 2 marks. And then there's an explanation mark, an E mark, for giving your conclusion and explaining why. So that's how those 3 marks are awarded. The other way you could have done that is, rather than working with Rosinas, you could have turned 28 into a percentage with Luigi. So you would have done 28 out of 65. But that was by far the most common way of solving that. Question 3, pie charts. Thomas is looking at gym memberships for Hayden's Gym and Workout Palace. Each of these gyms displays its membership in a pie chart. So we can see you've got women, men and children in each. About what percentage of the members at Hayden's Gym are children? So we've got the whole pie, and because this is talking about percentage, let's make the question bit stand out. Because we're talking about percentage, the whole pie will be 100%. And I'm hoping that you can recognize what a quarter of that would look like. And the children is a bit less than a quarter. So we're looking for a quarter as a percentage, which is a 25%. So I'm looking for one there to choose from, which is a little bit less than 20%. There's only really one that stands out, which is 20%. B, which of the following is the best estimate for the percentage of the members at Workout Palace who are women? So, I'm now moving to this one, and the children is a quarter. Yeah, that's a right angle. So I can take out a quarter of the pie, which is children, and these two look the same size. So if I take out 25% for the children, that leaves me 75%, which I'm then going to divide by 2. So 75 divided by 2, 37.5. So which of those is closest to 37.5? 38%. Part C. Thomas says there are more men with membership at Hayden's Gym than at Workout Palace. Is Thomas certain to be correct? You must give a reason for your answer. Now, this is one thing that when you're revising pie charts, you need to know how to read them, you need to know how to draw them, but you also need to know the pitfalls of comparing them. You can only compare pie charts if you know how many people each pie chart in total represents. So because you don't know that, we can't be certain, because you may have 1,000 people going to Workout Palace and only 10 going to Hayden's Gym. So, is Thomas certain to be correct? No. And then you want to write something like, because we don't know the numbers going to each gym. So you want to be saying something like that, that you can't compare unless you know the totals. Marks for that are straightforward. There's 1, 1, 1. So I'm looking to see those are correct. And with that one, if you just ticked the box and didn't put an explanation, you wouldn't get that 1 mark. In order to get that 1 mark, it has to tick no and have a because. Question 4. Scattergraphs. A group of friends measured the heights and masses of their pets. The scatter diagram shows the results. Describe the correlation shown by this scatter diagram. So with any graph, in class I will say pick something on the graph to make sure you understand what that's telling you. So if I was to pick this particular point here, if I read off the graph, this scale is height, this scale is mass of their pets. So that dot there represents a pet that's 25 centimeters tall and is 60 kilograms heavy. Its mass is 60 kilograms. Correlation, something you need to revise, but if you've got correlation where the dots or the crosses are generally increasing, as one scale increases, so does the other, that would be positive correlation. If as one increases, the other decreases, you've got negative correlation. Now here, they're all over the shop. So the correlation that this scatter diagram shows is that there is no correlation. There isn't any. The friends notice that the tallest pet has the same mass as another pet. What is the height of this other pet? So mass is this axis. So I'm looking to find two dots that are the same mass. So as I'm moving up the axis, I can see these two pets both have a mass of 30. And I want to know the height of the other pet. So the tallest pet has the same mass as another pet. What's the height of the other pet? 55. Okay, and again, that's just a straight 2 mark, one for no correlation, one for 55 centimeters. Question 5. Glenda plans to drive from Flint to Cardiff. On a long journey, her average speed is usually 42 miles per hour. Right, so I'm seeing speed and I'm thinking I've written something about that on my formula page. The last time she drove from Flint to Cardiff, it took her 3.5 hours. Use this information to calculate the distance between Flint and Cardiff. So I'm going back now to my formula sheet, unless I can remember it, and this is what I need to know. Speed is distance over time. So I'm going to write that now here in order to remind myself. And I want to find the distance. So covering up in my triangle, I know the distance. These are on the same level, so that's a multiplication. So the distance is the speed times the time, which is 42 times. Now, they've helped you here because they've given it you as 3.5 hours. So I can just write that in as 3.5. I don't need to use my time button. If they'd have written it as 3 hours 30, then you would need to be more careful. So this one, I've just got to do 42 times 3.5 is 147 miles.
If it was 3 minutes speed,
yeah,
and you did the time thing,
yeah, yes, well, I'll show you. Okay, so if we were going to do that as 42 times 3 hours 30 minutes, we would do 42 times 3 time button 30 time button 147. Okay, there you go, and if you press the time button again, it turns it back into normal decimal. Give a possible reason why your answer in A is only an estimate of the distance between Flint and Cardiff. Okay, so this is just saying her average speed. So she does it more than once. So the conditions might be different. It might be raining. She may take a slightly different route. The traffic might be heavier or less heavy. So anything like that would be a reason. You're better off talking about the conditions. Okay? So because, what was I going to say? Because the or it could be they're travelling from a different part of Flint to a different part of Cardiff. So what you're trying to do is put a practical context on why that might be. So with this one, the mark, so you got a method mark for showing that you're doing speed times a time, and then your answer mark for 147. And then you've got an E mark, an explanation mark for part B. Question 6. Gustav is making some scones for his sister's birthday party. So here we've got all the information we need to make 12. How much self-raising flour will he need to make 30 scones? So this is all about scaling up from 12 to 30. We've got to whatever we have to multiply by to go from 12 to 30, we would be multiplying everything else by the same amount. So to work out what that is, we do 30 divided by 12. 2.5. So in order to change the quantities in this recipe to make 30 rather than 12, I would have to multiply everything by 2.5. So for the self-raising flour, I've got to take 450 and need 2.5 times as much, which is 1125, which is that one. In the recipe, the temperature of the oven is given in degrees Fahrenheit. The temperature gauge on Gustav's oven shows degrees Celsius. The formula below is used to convert Fahrenheit to Celsius. At what temperature should he bake the scones? So there's my question. And they're telling me I want it in degrees Celsius, not just writing down 428. So the way this formula works is, instead of having F, I'm going to put 428. But because I'm then going from algebra to arithmetic, I need to break that F open and replace it with the 428. So all I've done is rewritten that formula exactly as it is there, but instead of the F, I've smashed that open and replaced it with a pair of brackets. Now, our calculators are brilliant things because I can type that into my calculator exactly as I've written it using the fraction button. So the fraction button, if you're not familiar with it, is where my pen is pointing now. Into the top of that, I can type in what I've written, and then moving down, a 9 on the bottom. This used to be much, much harder a few years back. If I press equals, I get 220. So, marks for that. Straightforward, 1 mark for the right answer there. And for the second one, there's a method mark just for writing that out and replacing the F with a pair of brackets with a number in front of it, and the answer mark for 220. (6b). Gustav also makes a birthday cake for his sister. The top face of the cake is the shape of a trapezium. Now I'm looking at that and thinking, I've seen one of those before. And it's there. It's one of the few useful things in the intermediate tier you were given. So they're actually giving you the formula there for that, where A is 15, H is 12, and B is 20. And the formula is area equals a half A plus B, 15 plus 20. Now the only thing you have to do here, which isn't helpful in the formula, is you have to put a times before the H. Otherwise the calculator gets confused. So with that formula there, in the calculator you actually need to put a times in. But you're given the formula. Just need to remember it's there. So back to my calculator. Amazing thing that it is, I can type that in exactly as it's written. So fraction button, half, open bracket, 15 add 20 close bracket, times, which is the only bit we've got to include, 12. Press equals, and we get 210. And that's an area, so the units of that are centimetres squared. There's no marks for that because they're not asking you to put it in, but it's worth doing. Okay, so we've done that. Part 2. How much will it cost to ice the top face of the cake? Well, I need some more information for that, so let's go back to the question. Gustav plans to ice the top face of the cake. Each packet of icing costs £1.35, and it's enough to cover 65 square centimetres. So my cake has got 210 square centimetres in it, and each pack covers 65 of those. So I need to work out how many packs I need to cover 210 square centimetres. 210 divided by 65. So number of packs will be 210 divided by 65. And that comes to that horrible number. 3.230769. You can. It doesn't matter. The most important thing is what you decide to do next. Okay? Because if I was to ask you to round that number, you'd round it to 3 packs. But in the context of what we're working with here, I wouldn't have enough ice in then. So because I need more than 3 packs, I've actually got to buy 4 packs. And they each cost £1.35. So the total bill for me is 4 times £1.35, which is 5.4, which in terms of money is £5.40. And then the last little bit of context for this. Gustav also plans to decorate the cake with small pieces of marzipan shaped as shown below. The top of each face is a rhombus. Will these pieces of marzipan tessellate? Now tessellate means will they fit exactly together without leaving any gaps? Okay? So some shapes do tessellate. You know, if you look at the tiles on the floor, they all tessellate because they will completely cover. These also, because of their shape, will. And all you have to do to earn the mark here is take yes and draw a little diagram showing that they all fit around each other. And that's enough for that mark. But tessellate is something that is an odd little thing in maths that we don't spend a lot of time on and isn't tested very often. So 6 part B, there's 1 mark for the method. So for writing that down, gets you a mark, and getting 210 gets you a mark. For the second part, there's 1 mark for the method of getting 3.23. Then there's a second method mark for realizing you need 4 packs. And then your answer mark for £5.40. And then that is, sorry, it's an explanation mark. So that's an E mark. So there's quite a lot of different maths going on in question 6. Question 7. Alan has made his own conversion graph to change knots to miles per hour. So we've got knots going in this axis, miles per hour going in this axis. Use Alan's conversion graph to write 150 knots in miles per hour. Okay, so we are going to look at the graph. We've got knots going across. The axis for 150 is going to be halfway between 100 and 200. So I'm going to draw a line up the graph and read across. So I've got to find out what value that represents. And what the problem that we got here is we've got a bonkers axis. Okay? But I can see that if I work out what's halfway between 0 and 115, I'll know what it's going up in. So if I do 115 divided by 2, that's going to tell me that that there is 57.5. Then it's going to be 115. Then it's going to be 115 plus 57.5. Which is 172.5. So to write 150 knots in miles per hour, it's 172.5. And there's just one straightforward mark for that. It's right or wrong. Then we come to part B. Nikita thinks Alan's conversion graph may be inaccurate. Nikita knows that 1,000 knots is 1,150.799 miles per hour, correct to 3 decimal places. Convert 20 knots to miles per hour. So that's what they want us to do. First of all, using Alan's conversion graph, and then using Nikita's values. Then calculate the difference in miles per hour between our answers. Then give your answer to 2 decimal places. There's a lot they're asking you to do here. First of all, we're going to use Alan's graph. So using Alan's graph, 20, where are we? What are we doing? 20 knots. Well, 20 is a pain to work out here, but what's easier is I can read 100 off straight away, and then if I divide that by 5, it'll give me 20. So from Alan's graph, 100 knots is 115 miles per hour. So if I divide that by 5, it gives me 20 knots. And if I divide that by 5, I have to do the same here. So I do 115 divided by 5, and I get 23 knots. Sorry, 23 miles per hour. So 23 So 20 knots on his graph is actually 23 miles per hour. Then we come to Nikita. And she says that 1,000 knots is 1150.779 miles per hour. That's one hell of a thing to know. And I now need to turn this into 20. So if I do this in 2 stages, unless I know how many times 20 goes into 1,000, if I first of all divide it by 1,000, that would give me 1 knot. And then to work out 20, I would times it by 20, and that will give me 20 knots. Now if I'm going to do that to this part of the relationship, I've got to do the same over here as well. So I'm going to have to divide that by 1,000 and then times that by 20, and that will give me the equivalent. So on my calculator, I do 1150.779 divided by 1,000 times 20. 23.01558. Now, because this question is a rounding question, give your answer correct to 2 decimal places, I would really recommend, before you start messing with the rounding, you write that whole calculator string out, because there's going to be marks for that. And if you round incorrectly and you don't show that, you could be penalized. So calculate the difference in miles per hour between my answers. So the difference will be the difference between 23.01558 less Alan's graph, which was 23. So there's that difference, which we now, to earn the last mark, need to turn into 2 decimal places. 2 decimal places, you start counting for decimal places after the decimal point. So that's my first, that's my second. I then look at the next. If the next is 5 or more, it's closer to the next value, so you round up to 0.02 miles per hour. So the way that that one is marked is you get 1 mark for using Alan's graph to get 23 miles per hour. You got a method mark for doing the divided by 1,000 times 20, and an answer mark for the 23.0558, and then finally I'm looking for a correctly rounded value. Now if you've done anything wrong in your maths up there, but you correctly round your wrong answer, you get a mark for it. So that is independent of whether or not you get the maths right further. Because the question, calculate the difference in miles per hour between your answers. Yeah? That one wasn't very well answered last summer on the intermediate tier. Lots of people got the 23, but then didn't know what to do with this information. So that's question 7. So we got 2 more to do from the foundation tier. Question 8. Mrs. Rashid gave her Year 9 French class a test on Wednesday. She asked her class to spell 12 different words. She displays her results as shown below. So let's make sense of the graph. Let's take a look at this here. This is telling me that 5 people scored 3 marks on the test. Okay, it's at one of those scales that's going up in 2 squares to be 1. So this is telling me 1 person scored 1 on the French test. this is telling me 2 people scored 4. And I'm going to write these numbers on top of every single one, because it's going to make interpreting it that much easier. So I got 1, 5, 2, 2. This is 2 down from 15. So that represents 13. That represents 3. And that represents 2. How many pupils scored more than 9 in the test? So this is a language thing now. You've got to be clear whether these 13 kids that scored 9 are part of that answer. No, they're not, because it's more than. So the pupils that scored more than 9, it's easy now because we put the numbers on it. 5. How many pupils are there in Rashid's French class? Just going to add them up. 13, 16, 18, 20, 22, 27, 28. How did I get what? 5. More than 9. So 3 kids scored 10 and 2 kids scored 12. So more than 9 is 5. Okay? So to get the 28 then, I'm adding all of those up. Then I've got one of my wordy bits. What assumption have I made in answering part 2? So part 2 is saying how many kids are there in the French class. I've got 28 by adding those up. For that to be the number of kids in the French class, it means they must have all been absent. None of them must have been absent to do the test. Okay, so something like there are no absences, or everybody sat the test, something like that. So there's a B mark, I just need to see 5. A B mark, I need to see 28. And an E mark, I need you to make sense of the context of the question. Poppy, Miss Rashid also gave the same test to her Year 10 class. She asked her class to spell the same 12 words. She displays the results as shown opposite. So, similar graph. And what I want to do now is exactly the same as I did previously. I want to write numbers on here so that it gives me a better sense of what's going on. So it's the same scale, it's the same axis. So that's going to be 2, 4, 16, 2, and 2. Leon says, by looking at the Year 10 graph, I think there is very little difference between the mode and the mean for these scores. Without calculating the mean, so we don't have to do the maths, explain whether Leon is correct or not. Well, the mode stands out a mile. It's 16. And the mean, you'd have to add all of those up and divide by the number of people. And because there are so many that are around about the 16, there is going to be very little between them. So it is correct, and it's correct because the mode is so much bigger than any others. The mean will be similar. Okay, you got so many kids out of the class that got 16 that when you add them all up and divide by however many there are, then it's going to be 16 point something. Catherine looks at the 2 sets of data Miss Rashid has displayed. She says, Year 10 are better at spelling than Year 9. Is she correct? You must give values to support your answer. So again, if you just tick one, even if you tick the right box, you won't get the mark. So let's take a look at being good. If you're a good speller, you're going to be up here. If you're a good speller, you're going to be up here. So if we take a look, if I could fit the two in there. If we look at year 9 and we look at where most of the students are, how many students got at least 9? 13, 16, 18 of them got at least 9. Whereas in year 10, although the spike is in a similar place, it's actually on a different question. Only 4 kids in year 10 got at least 9. So she's not correct because 18Y9 pupils scored at least 9. But only 4 year 10 scored. Now there are different ways of arguing that. You could argue it the other way around, but that's the easiest way for me to stand out. Okay? So we got an E1 and an E1. Then we come to question 9. So this is the last question that's on the foundation tier overlap. But it's 2 big parts. Organics for You is planning to have its headquarters in Wales. The manager has instructed Ffion to look for a site for the headquarters. Here are the instructions that Ffion has been given by her manager. Find the point that is an equal distance between Wrexham and Aberporth, and an equal distance between Carnarvon and Swansea. The new headquarters needs to be within 20 miles of this point. On the map below, shade the region in Wales that Ffion should identify for her manager. At this point, you need to be getting those out of your pencil case, because this is a loci question. Okay? Aaron, when you come to the real thing, right, and you, Harvey, make sure you get a smaller pencil. Oh, okay, fair enough. But when you buy one of your own, yeah? Now, you don't have to construct on this because it's not telling you to, but it's actually easier to do this if you revise loci. It's easier to do this as a proper construction. So I want to find the point that's an equal distance between Wrexham and Aberporth. So what we need to do from a loci point of view is bisect that line. So if you revise this, this will come to you. If it doesn't, if you haven't revised this, then you go, oh God, I can't remember doing this. You need to open your compass so it's over halfway between the 2 points. Okay, so I'm going between Aberporth and Wrexham. I've opened my compass so there's more than halfway. You then take the compass point, stick it in Aberporth, and draw part of a circle. If it helps you, you can draw a line. What you'll notice is that when we finish this, you're going to have an awful lot of constructions on your diagram. So it does get a bit confusing. But yeah, you can do that. That's okay. Then we're going to move the compass point to Wrexham and draw the second side of that curve. Like that. And then you join a line through that intersection. Everywhere on that line is exactly the same distance from Aberporth as it is from Wrexham. So my region is going to, that line's going to have some part to play in my region. So I've done that first rule, an equal distance between Wrexham and Aberporth. Now I come to the second rule, which is an equal distance between Carnarvon and Swansea. So we've got to do the same again now, but this time, if you want to join it first of all, we need to bisect the line between Carnarvon and Swansea. So we have to do the same again, get our compass, open it so it's visibly over halfway, and try and keep track on what's what. So I need to draw another one of those from Swansea and take the point to Carnarvon and draw another one, and then join those together. So I've done that in green. So everywhere on that green line is exactly the same distance from Carnarvon as it is from Swansea. So find the point that is an equal distance from Wrexham and Aberporth, so is on the red line, and an equal distance from Carnarvon to Swansea, so it's on the green line. So the only place that's of an equal distance from both pairs of those is where those two lines cross. But that's not where the HQ is going to be. The headquarters needs to be within 20 miles of this point. So this now is another loci where it's an equal distance from a point, 20 miles. So now you're going to get your compass and you're going to open it out using the scale they've given you to 20 miles. Put the compass center where our two lines have crossed and draw a circle. The new headquarters needs to be within 20 miles of this point, so it needs to be inside that circle. But, and very, very, very few people got full marks on this, on the map, shade the region in Wales that Ffion should identify for her manager. So it isn't anywhere at all inside that circle. It's actually just the parts inside that circle that aren't in England. So I'm shading in inside the circle, but making sure that they can see I'm not including Wales. So that was a really horrible question. Horrible to mark as well. There's 4 marks for that. So there's 1 mark for that red line. There's 1 mark for the green line. There's 1 mark for the circle. And there's 1 mark for correctly shading in and not colouring in the bit in England. So loci, it's not a hard thing to revise. Okay, and there's clips on my website and from the work we did back in December on that. So it is worth going and having a play with that. So then the final question before we say goodbye to Foundation Tier is our OCW. Okay, so this is where we're going to pick up 2 marks for just being organised in our maths. Organics for You has 16 vehicles on the road every working day. The company has 6 vans and 10 trucks. Ffion has the following information for each type of vehicle. So vans and trucks The average distance travelled per litre. So the van will go 8 kilometres on a litre of fuel, whereas the truck will only go 5.5 litres. And the vans on average travel 256 kilometres a day, and the trucks 704. The fuel used by all 16 of the vehicles cost £1.10 per litre. What's the question? Use the information to calculate the total fuel bill for one working day. So we've got to pull out of all that information now the cost of the fuel. Well, let's separate vans and trucks. What do I know about vans? I know they've got 6 of them, and I know that the fuel consumption is 8 kilometres a litre, and they travel 256 kilometres in a day. So fuel needed for one van, 256. I want to see how many 8s fit into it, because each 8 is 1 litre of fuel. So I'll do 256 divided by 8, 32 litres a day. That's for one van. We've got 6 of them. $32, lots of 6. 192 litres. Each litre of fuel costs me £1.10. So cost of fuel for vans, I need 192 litres, and every litre is £1.10. So £211.12. That's how much the fuel costs per day for the van. Now I'm going to do all of that again, but for the lorries. So first of all, how much do I need for one lorry? $704 miles in a day, and every kilometre, takes 5.5 litres. So 704 divided by 5.5, 128 litres. Truck, yeah. So one truck takes 128 litres, and we've got 10 of them. So for 10 trucks, 128 times 10, okay, don't need my calculator for that. So that's going to be 1,280 litres. Each of those is going to cost me £1.10, or cost them £1.10. Cost of fuel for trucks. £1,408. Okay, so I know the fuel for the trucks cost me 1,408. The fuel for the vans cost me £211.12. To answer the question, I need the total fuel bill. Oops. So £1,619.12 per day it's cost them to run.
Why do you times it by £1.10?
I need, for the trucks, I need 1,280 litres,
Yeah.
and I want to find out how much that's going to cost. And the cost per litre of the fuel is £1.10. So lots of maths going on there, but it is repetitive. So for marks, you're going to get a mark if I see 32 litres or 128 litres, depending on what one you do first. Then you're going to get 3 marks for coming up with the £211.12, the maths for that, as well as the maths for the 1408. You get 2 marks for then adding those together and coming down and getting that final answer, with lots of possible additional, or not additional, but marks in there if you make a slip. As far as the OCW is concerned, the OCW is for being organised. So the fact I've separated vans and trucks, and then I'm saying just what that line of maths is doing. Why am I doing 256 divided by 8? And then the second OCW mark is for being consistent with units. So I'm not just seeing numbers. I know that here I'm talking about litres of fuel, and there I'm talking about money. Litres of fuel, money. So just having those units in your answers will pick up those OCW marks. All right. So we'll take a quick stop there.